In lesson 7.3, we're doing more multiplication powers with exponents. We're actually going to be raising a power to a power and raising a product to a power. As we do that, the key thing to understand is that when you work with your exponent, to simplify a power raised to a power, you can use repeated multiplication. Now, 5x to the fifth raised to the second means I have 2x to the fifth. So when I multiply that, my rule says I would be adding. So instead of adding 5 plus 5, I can just take 5 times 2, which gives me 10. So notice raising a power to a power is the same as raising the base to the product. In words, raising a power to a power, you multiply the exponents. If I have a to the m and it's raised to the m, I can take a and multiply m and n. Only when a is not 0 and m and n are rational numbers. So if you have 5 to the fourth raised to the second, you're now going to end up with 5 to the eighth. And if you have a to the 3/2 raised to the third, we're going to multiply that, and we're going to have 3/2 times 3, which gives us 9/2. Here are a couple more examples to take a look at. In problem 1 that you're going to put in your notes, it says multiply the power raised to a power. So how do we simplify this? We just said our rule was that we are going to multiply. 4 times 7 gives us n to the 28. It says should you add or multiply exponents to simplify? You multiply when you're raising to a power. But remember, if you have x to the second times x to the third, then you are going to be adding those exponents. Here we have x, where we're taking to the 2/3 raised to the 1/2. So we're going to take 2/3 times 1/2, which when we multiply, we should be looking at x to the 1/3 as we simplify. It's your turn to try these on our guided practice, and then we'll look at this explanation. So pause the video if you need to and try these. And now you should see your solutions. P to the 20th. P to the 20th. Here we're going to take p to the 1/2 times 1/4, which will give us p to the 1/8. And here we're taking 3/4 times 1/2, and we would end up with p to the 3/8. This last question is asking you something to think about. Is a to the m raised to the nth power the same as a to the n raised to the m? And it says, is it true for all integers m and n? So as you think about this, what I would like you to do is to try different values of m and n. Now, if it's 2 and 3, does it work? Definitely. What about if one of them is negative? What about thinking about different possibilities of integers that we're going to raise to a power? So we're going to talk about this in class. Take a look and see if you can think about that and explain your answer. It says to use order of operations when you simplify. So here we are looking at simplifying this expression. It says what is the first step to simplifying? By the order of operations, you simplify powers before you multiply. So here we have y to the third times y to the 5/2, and that's raised to the -2 power. First thing we're going to do is we're going to multiply these two so that we have our y to the third, y to the fifth times that -2 actually is going to give us just a y to the -5. Remember, because when we multiply this, we have -10/2, which we could just put as a y to the -5. Now we're going to add our exponents. If we add those exponents together, we are going to end up with y to the -2, but we can't have any negative exponents. So our answer is 1 over y to the second. In your notes again, if we are looking at these, one of the things that you would now want to take a look at is putting in our notes these 3 examples for our got it questions. So again, if I'm simplifying this, and if you want to pause the video and try these on your own, that might be a really good idea. Here we're going to start and keep x to the second. We're going to multiply 6 times -4, which gives us a -24. I would then end up with 6 to the -22nd, which is x, 1 over x to the 22nd. Here we have w to the -2. And then we have w to the 5/3 times 3. Now remember, when you take 5 over 3 times 3, or 3 over 1, those are actually canceling. So we have w to the negative 2 times w to the 5th, which should give us a solution of w to the 3rd. S to the negative 5 raised to the negative half power is going to give us s to the 5 halves. And we have that times s to the 3 halves. Well, now we're adding. When we add those ones together, we're going to have, since we have a common denominator, 5 plus 3 gives us 8 over 2, which is simply going to be s to the 4th. It says you can use repeated multiplication to also simplify these problems. Key thing you want to remember is that this to the 3rd power means that the 4 has to be raised to the 3rd, and then we're going to take the 1/2. So you could write it out 3 times. 4 times 4 times 4, 3m to the 1/2 power, or you can simply multiply. When we multiply, that means you have to use kind of like the distributive property. 4 to the 3rd, m to the 1/2 times the 3. So that we get this solution, 4 to the 3rd, m to the 3/2, and 64 over the 3/2. Now you're also going to have what's called the product to a power, and that says that when you raise a product to a power, you have to raise each factor to that power. If I have a and b both raised to the n, I have to take a to the n and b to the n. Again, a and b cannot be 0, and n has to be rational. So again, we're going to take, we could write this out 4 times, but we're going to write it as 3 to the 4th and x to the 4th. To evaluate it, 81x to the 4th. 4 to the 3/2 and b to the 3/2. Now again, we got to go back to the lesson we did the other day when we simplify that 4 to the 3/2. So kind of using that, thinking of it as 4 to the 1/2, 4 to the 1/2, remember how we did this? And 4 to the 1/2, we have to have it 3 times. Remember, that's the square root of 4, which was the 2 times 2 times 2, that's how they came up with the 8. If we look at problem 3, in problem 3, it says if we simplify by raising to a power, and here it says which expression gives us the area. Well, if we have 5x to the 3rd, that means we are going to take 5x to the 3rd, and if we are finding the area, we want to square it. So as I talk about that, they say we have to square the 5, and then square the x, 3 to the 2nd power, which gives us x to the 6th. And we should have had 25x to the 6th. It's your turn to try it now on these last questions. Try them so that we're ready in class. And again, we have about one more example that we're going to look at. Here we would have 7 to the 3rd and m to the 9th times 3. 7 to the 3rd. We're going to take our 49 times 7. And here we're going to multiply it, so be ready to show your answer tomorrow in class. Here we're going to take 2 to the negative 4 power and z to the negative 4. Now remember, we can't have any negative exponents. So what our answer is really looking at is 2 to the 4th and z to the 4th. 2 to the 4th gives us our 16, so we are looking at a solution here of 1 over 16 z to the 4th. Could we have made this positive right away? That's another thing that you could do. You could make it positive right away. 1 over 3g to the 4th to the 2nd power. We could have done that with this one also. We still have to take the 3 to the 2nd power and g to the 4th to the 2nd, which gives us g to the 8th. So our answer here is 1/9 g to the 8th. So there's a few different ways of simplifying. In one of these last examples, again, we're going to be doing some simplifying. It gets a little ugly. Key thing, it's implied if m is not raised to a power, if there's a 1. And as you look at this problem, one of the things that they say first is let's raise this whole thing to the 3rd power first. This to the 10th. Now, this is nice to take to the 10th because when we're taking it to the 10th, we are actually going to multiply those. And if we do that, we're going to end up with n to the 5th. We're going to take 4 to the 3rd m to the third, and n to the negative 2/3 raised to the third. Well, what's nice when we multiply that is we should have m to the third and n to the negative 2. Now we're going to have 2 at the same base. Since we have that, we're going to write it as 4 to the third, m to the third, and here we would be taking 5 minus 2. So again, we'd be looking at 4 to the third, which is 64, m to the third, and n to the third. As you try it in these next problems, as we are taking a look in our got it problems, I'm going to do at least one of them, and then you can take a look at the other two, and we'll look at them in class if you have questions. Here we are going to look at multiplying. That gives us a negative 4. Times, we have 3 to the 4th. X is going to be to the 4th, and y, when we multiply, will be to the 20th. X to the 4th and negative 4th, we are still going to have 3 to the 4th power. That's going to give us x to the 0, which is 1, and y to the 20th. So in simplified form, we have 4 3's that we're multiplying. That gives us 81, y to the 20th. Please try the next two, and if you have questions on them, we'll look at them in class. We are going to talk a little about simplified scientific notation, but again, this is not a big standard that we are looking at. So if you look at this problem with raising scientific notation to a power, you're going to take a half times, we're looking at, in this case, the mass, 1.3 times 10 to the third, and then times the speed, which was 3.1 times 10 to the third raised to the second. So looking at what our formula was, m and v squared. Here we're going to square both of these. So we have the 1.3, as we are looking at that, times 10 to the third. 3.1 is squared, and this becomes now a 10 to the 6th. So when we multiply with our powers, a half times 1.3, 10 to the third, 3.1 squared, and 10 to the 6th. We're now going to use our commutative property and rewrite it. And again, when you're doing these in your homework, you probably don't need as many steps as I have here. Again, when we look at that, we should now have 10 to the 9th power. And we're going to multiply all those together, and it actually comes out to be 6.254. I'm not too worried that we do the got it problem here. And as we take a look, just make sure that as you're looking at this, that it kind of makes sense to you.